Namaste, and welcome back to JEE Mathematics with Typical Monk. This is class 37, Vectors. A vector is a quantity that carries both a size and a direction, a displacement, a velocity, a force, and it obeys a geometry all its own. Vectors add tip to tail, or by the parallelogram law, and any vector splits neatly into components along the axis, written in terms of I, j, and k. Two vectors can be multiplied in two very different ways. The dot product, which returns a scalar, the magnitudes times the cosine of the angle, and is zero when they are perpendicular, and the cross product, which returns a vector, the magnitudes times the sine of the angle, perpendicular to both and zero when they are parallel. Master these two products and their geometry, and vectors unlock mechanics, geometry, and three-dimensional space. Today, components, addition, and the dot and cross products. One idea at a time. Here is what you will master today. First, vectors and their components. Second, addition and scalar multiplication. Third, the dot product. Fourth, the cross product. And fifth, their applications. One idea at a time. Let us set the foundation. A vector, a quantity with magnitude and direction. A scalar, a quantity with magnitude only. Components. Any vector splits along the axis in terms of I, j, and k. Master line, vectors add tip to tail and split into components. Now look at the picture. The parallelogram law. Tip to tail. Place P at the head of A. The sum runs from start to finish. The parallelogram law. The resultant is the diagonal. Components. Add the matching components to add the vectors. The magnitude. The square root of the sum of the squared components. Now the basic operations. The unit vector, magnitude 1, a hat equals A over the magnitude of A. The magnitude. The square root of the sum of the square of the components. Addition. Add the components or use the triangle law. The scalar multiple. It scales the length and negative sign reverses the direction. Now the dot product. The dot product. A dot B equals the magnitude of A times the magnitude of B times cosine theta, a scalar. In components, a dot B equals a 1b1 plus a 2b2 plus a 3b3. Perpendicular. If a dot B is 0, the vectors are perpendicular. Projection. The projection of a on B is a dot B over the magnitude of B. Use it to find the angle between two vectors. Now look at the picture. Dot against cross. The dot product. A dot B equals the magnitudes times cosine theta, a scalar. The cross product. A cross B equals the magnitude times sine theta, a vector. Direction. A cross B is perpendicular to both by the right-hand rule. The magnitude of a cross B is the area of the parallelogram. Now, the cross product in full. The cross product. A cross B equals the magnitudes times sine theta times n hat a vector. The direction. Perpendicular to both by the right-hand rule. The magnitude. Equal to the area of the parallelogram. Parallel. If a cross B is 0, the vectors are parallel. It is anti-commutative. A cross B equals minus B cross A. Now a worked example. The question, are the vectors A and B perpendicular? The test, compute the dot product, a dot B. The answer, if a dot B is 0, then yes, they are perpendicular. Now match each form to its meaning. The magnitudes times cosine theta goes to the dot product. The magnitudes times sine theta goes to the cross product. A dot B equals 0 goes to perpendicular, and a cross B equals 0 goes to parallel. 4 pairs, each worth memorizing. Now, how many of these statements are correct? Statement 1. The dot product is a scalar. Correct. Statement 2. The cross product is a scalar. Wrong. It is a vector. Statement 3. If a dot B is 0, the vectors are perpendicular. Correct. So the answer Two are correct, statements 1 and 3. The trap is the cross product in statement 2. Now, the two mistakes that quietly cost marks. The truth, the dot product gives a scalar, the cross product gives a vector. The trap, forgetting the right-hand rule for the cross product's direction. The second truth, a dot b equals 0 means perpendicular, a cross b equals 0 means parallel. The second trap, treating the cross product as commutative, it is anti-commutative. Now test yourself, answer in your head before the reveal. That is how G-speed is built. Here we go. Question 1. The dot product, the magnitudes times cosine theta. Question 2. The magnitude of the cross product, the magnitudes times sine theta. Question 3. A dot b equals 0 means perpendicular. Question 4. A cross b equals 0 means parallel. And question 5. Is the cross product commutative? No, anti-commutative. Let us gather it all in one breath. A vector has magnitude and direction. Add tip to tail, or add the components. The dot product, the magnitudes times cosine theta, a scalar, if perpendicular. The cross product, the magnitudes times sine theta, a vector, 0 if parallel. The cross product magnitude equals the area of the parallelogram. Next class, three-dimensional geometry. The algebra of arrows. A vector is an arrow that mathematics learn to compute with. It carries a size and a direction at once, adds tip to tail or by the parallelogram law, and resolves cleanly into components along J and K. Its two products are the heart of the chapter. The dot product hands back a scalar, the magnitudes times the cosine of the angle, vanishing exactly when the vectors are perpendicular. The cross product hands back a vector, the magnitudes times the sine, perpendicular to both by the right-hand rule, vanishing when they are parallel, and its length is the area they enclose. Learn to read those two operations, and vectors become the language of forces, planes, and the whole of three-dimensional space. Next class, three-dimensional geometry. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time. You'll crack G. I will see you in the next class.